Okay, one type of equation that is fairly difficult to really wrap your hands around it is a logarithmic equation. Now, what I like to do is I always want to change an equation that has the word log in it into an equation that has exponents in it. Now we know that the word log is just a mathematical synonym for exponent. So for example, when you're asking log base 10 of 100, you're just saying, what is the exponent I have to raise 10 to in order to get 100? So log means exponent. Now, the equal sign means is. So what I want to do is when I see a logarithmic equation, I want to first of all come up with the English words that'll help me transform it from a log equation to an exponential equation. So when I look at the word log, in my mind, I'm thinking exponent, the word exponent. When I see the equal sign, in my mind, I'm thinking the word is. So in this equation here, log base 2 of x is equal to 3. I'm thinking in my mind the exponent is 3. What is the base? 2. So now we can take that and we can transform that into an exponential equation. And sure enough, there we have 2 to the third is equal to x. Now, how did I get that? Again, exponent is 3. The base was 2. So x is equal to 8. Okay, let's look at our next equation. Now, the previous equation, the log term was isolated in the equation. But let's look at this next equation. 2 log x plus 1 is equal to 5. Here, the log term is not by itself. First of all, we're doubling it. And then next, we're adding 1 to that term. Whenever you have a logarithmic equation, you want to get the log term isolated. Now, notice there's no number at the lower part of the g. That means the base is 10. So if there is no number at the lower portion of the g, the base is equal to 10. Okay, so what we want to do is get the log term alone. So the first thing I'm going to do is, just like in any regular equation, subtract 1 from both sides. So now we get 2 log x is equal to 4. Well, log is still not isolated. There's a 2 multiplying it, so divide both sides by 2. Log x is equal to 2. Now, this equation looks very much like the first one. So what do? We say to ourselves, we have a log equation, we want to rewrite it as an exponential. You see the word log, in your mind you think exponent. You see the equal sign, in your mind you think is. So this says exponent is 2. What is the base? It is 10. So 10 to the 2 is x. X is equal to 100. Okay, let's come to our final equation. Now remember the properties of logs. If you're adding logs together with the same base, it becomes the log of the product. If you're subtracting logs with the same base, it becomes the log of the quotient. So here we're adding logs together, so that becomes the log of the product. It's still base 2, x times x minus 2. Now again, we want to change it from a log equation into an exponential. So when I see the word log, I'm thinking exponent. When I see the equal sign, I'm thinking is. Exponent is 3. What is the base? 2. So x times x minus 2 is equal to the base 2 raised to the exponent 3. Okay, so the next thing we're going to do here is, first of all, we're going to distribute the x times x minus 2. That gives us x squared minus 2x equals 8. Subtract 8 from both sides. X squared minus 2x minus 8 is 0. Now, this is a trinomial. You can factor it using the x method, and that was a video I made available earlier in the semester. And you factor it to get x minus 4 times x plus 2 is 0. Set each factor equal to 0. X is 4, x equals minus 2. But now, not both of these solutions are going to be accepted, because if we go back to the original equation here, You cannot take the log of a negative number. You can only take the log of a number bigger than 2. Now, if x is 4, that's fine. Log of 4, that's a log of a positive number. You come over here. If x is 4, 4 minus 2 is positive. That's good. But if x is negative 2, the other solution from the quadratic, you cannot take the log of a negative number. The log of negative 2. It's mathematical nonsense. So you have to reject this root negative 2. So here, there is only one answer. X equals 4.